I want to elaborate in this video a little more on the velocity and acceleration vectors for something moving in a circle. So let me draw a circle on the screen. So imagine that something was moving in that circle, an object, a mass, under the influence of a centripetal force. All right, so let's put a dot maybe where the object is located. So and let's assume it's moving at a constant speed. All right, so the velocity vector, what does that look like for something moving, let's say, counterclockwise in this circle? The velocity vector is always tangent to the circle. The motion is always tangent. All right, so the velocity would look something like what I just drew there on the whiteboard, tangent to the circle. Now at a different point, okay, like for example, if the green dot, if I put another green dot at another point, it would still be tangent, but tangent is going to mean something else at that different position. So there I would put the velocity vector that way. Okay, so maybe we'll call that v1 and v2. So it's clear that the velocity, the direction is always changing. Now I said that the speed is the same. Okay, so a lot of times it takes a while for people to for this to click with people, but what's happening with the velocity vector is that you have the direction changing but not the length. Okay? Now, what is the acceleration vector doing? So we said that the magnitude of the acceleration, the centripetal acceleration, was v squared over r, where r is the radius of the circle. So the acceleration is always towards the center. That's what centripetal means. And the strength, the length of that vector is constant. Okay, so all of that is to say that just like the velocity vector, the direction is constantly changing, but the length stays the same. Okay, now later on in another video we'll learn that you can have tangential acceleration. You can be speeding up along the circle. You don't have to keep the same speed. But for right now, to keep things simple, for something moving in a circle under the influence of a centripetal force with a constant speed, it'll have a velocity vector that the direction changes but the length stays the same, and the centripetal acceleration, the net acceleration, the direction will keep changing but the length of that will also remain the same.